A very good morning. I am alekhya kumari here to emphasize on improvement of pig iron production by high alumina iron ores with my partner Visual Vemla from JNTUH-CEH. As of 2018, India is first in sponge iron production, second in crude steel production, third largest consumer of finished steel. In spite of these rankings, it is facing some challenges, and some of the challenges are finance, tax, duties and SaaS, environment and energy consumption, logistics and raw material. Out of these, raw materials is key challenge we are facing now. Although India has abundant reserves of iron ore and coal, it has negligible reserves of coking coal. 68% of steel making through blast furnace route requires 180 million tons of coking coal. Raw material and the commodity are bulk, so they are very difficult for transportation. India imports coking coal from Australia with high fluctuations in supply and price. 60% of Indian iron ores reserves are hematite with 70% metallic content and 6 to 7% of alumina. They are richly found in the states of Orissa, Jharkhand, Chhattisgarh and Karnataka. Dealing with high alumina ore is tedious in nature. Utilization of high alumina iron ore is given more significance. Indian hematite ores are typically rich in iron, but they contain high alumina. Blast furnace iron making with high alumina iron ore has the operational difficulties like high operating temperature, high liquidation temperature of blast furnace slag, and higher coking rate. Alumina being acidic, it decreases the basicity of the slag, thereby leading to a thicker slag formation. Role of alumina in iron production. Alumina has its own effect on sinter. Most harmful effect is it worsens RDI value for CaO of 10 to 10.5 and increasing 0.1% of alumina increases RDI by 2 points. Alumina increases the viscosity of the primary melt. It weakens the sinter structure. It promotes excess accumulation of molten slag in the earth region and increase in the pressure drop at lower parts of the furnace. It has the adverse effects. Some of these are it has greater tendency towards silicon reduction, thereby increases the silicon level in the hot metal. Presence of alumina makes the slag very viscous in nature, thereby decreases the transport of ions of gangue particles from metallic ore to the slag. Sulfur in metal increases as alumina content in the slag increases. So ultimately, high alumina slag contributes to less efficient desulfurization. So now my partner Visual Vemla take over this.
Thank you, Alekhya, and good morning, all. This is Visual from JNTU Hyderabad. I will be continuing the presentation. Alumina in steel comes from deoxidation and wear of alumina refractory and is present as inclusions in the steel. So these are the inclusions you can see here. This one, and these are all the inclusions. These inclusions degrade the properties of steel, especially the mechanical properties. They are brittle in nature, and as a result, while rolling, they break, causing serious surface defects. When they coalesce, they form irregular clusters, which degrades the toughness and fatigue life of steel. Even while casting of steel, alumina accumulates in nozzle, which results in clogging of that nozzle. Coming to recovery techniques and remedies, one of the research-based recovery technique is magnetic separation of our Sanja iron ore and iron ore in Zambia. Series L model for magnetic separator has been used with wire mesh or pipe as matrix of a magnetic particle collector. Magnetic density is varied from 3000 to 10,000 millitesla and pulp density is varied from 2 to 10% with a constant flow rate of 7 liter per minute. Coming to magnetic flux density variation, if we vary it from 3000 to 10,000 millitesla, recovery has increased from 76% to 93%, and silica content has decreased from 19.98% to 18.79%. And if we increase more than 10,000 millitesla, there is a decrease in recovery. And coming to pulp density, at constant magnetic density of 10,000 millitesla, from 2 to 2.5%, recovery has decreased from 93%, and if we keep on increasing the pulp density, there is constant recovery. Optimum recovery has been obtained at 7.5% pulp density, that is 89% of recovery. At this pulp density, the content of iron ore is 49.72% and alumina is 4.19% and silica is 18.08%. And coming to type of matrix, expand metal, which is my wire mesh, has 89% recovery with 49.70% of iron content, and pipe metal has 93.93% of recovery with 51.38% of iron. Here are some chemical methods to decrease the effect of alumina in BF iron making route. We can increase magnesia content in BF burden. It is helpful as it suppresses the increase of permeable resistance in cohesive zone. Magnesia helps in maintaining good slag drainage rate. It also decreases sulfur content in hot metal. Addition of extra slag forming elements dilute the concentration of alumina in slag, but this is just an occasional remedy because if we keep on adding slag forming elements, slag volume increases but productivity decreases. Alumina inclusions in liquid steel are present in solid state. To convert them into liquid state, we can add calcium to liquid steel as it forms calcium aluminates with those inclusions, which has low melting point as low as 1600 degrees centigrade. Liquid phase content increases with lime. For 100% liquid phase, 35% lime is enough. The minimum melting point of calcium aluminates is 1400 degrees centigrade, that is, they will be in liquid state even after steel solidifies, or at least until steel solidifies. In this slide, we will see about an experiment in which samples of iron ore from Normandy and Joda have been exposed to high intensity power ultrasound of 20 kHz for 5 minutes. After the experiment, good results have been obtained in terms of decreasing the content of alumina and phosphorus. As you can see the figures of Normandy iron ore, before and after exposure, the alumina content have been decreased from 1.7% to 0.05%, and the same happened in Joda iron ore also. Phosphorus content is also decreased, as you can see. And finally, the conclusions will be as follows. External desulfurization is not favorable as sulfur content in hot metal tends to increase with alumina content in slag. Addition of lime and or magnesia to form ternary and quaternary compounds with alumina would be handy. Beneficiation of iron ore along with the above discussed methods in this presentation will help in decreasing alumina content in BF route of iron making and steel making. Addition of silica to decrease alumina by silica ratio, that is decreasing the basicity, will decrease the viscosity of slag. Addition of silica increases the silicon content in hot metal, which can be reduced by external desulfurization afterwards. Internal refining must be desulfurization and external refining must be desulfurization. Calcium treatment to high alumina steel will help in improving the castability of steel as lime forms low melting point calcium aluminates, and these aluminates remain in liquid form even after the steel solidifies. Thank you for the opportunity.